Thank you. As Pradeep had mentioned, Nexion is a small startup company. We actually moved here to New York to develop the technology that I'll tell you a little bit about. We are a small company. The three people sitting over here with me and a few others, that's pretty much the entire company. Well, what we've been doing is focusing on several different technologies that we're working here at CNSC to develop. This one that's specifically dealing with energy efficiency is our primary focus. And CO2 emissions, reduction of CO2 emissions, reducing the demand for energy and so forth. Certainly low-hanging fruit, as a lot of people have described. It's something that we're focusing on primarily, and it is something that almost anyone can really get their arms around. The average American produces about 40,000 pounds of CO2 emissions, so CO2 emissions, of course, being one of the primary drivers of trying to drive down the use of fossil fuels. And what we have looked at as one of the weakest parts of the building, and that being the window. So as we look at the windows and so forth, one of the good examples of a window and a retrofit type environment is what has been done at the Empire State Building over the last few years. For most of you who have probably followed this, it's gotten a lot of visibility, and there are 8 different initiatives that were integrated into this retrofit project. One of the major ones there, of course, was the windows. As a result of the work that they did, they quadrupled the thermal performance of the 6,514 windows that they actually reworked. And as windows being a primary driver of the energy conservation and usage, that was a big deal. Now, what they've done in this environment is they end up having to rebuild the entire window systems, which, as you know, is a very costly prospect. So one of the things we're looking at is how do we simplify that and improve the return on investment and simplify the retrofit process. The film that we have developed basically will help us get there and make it easier, less expensive, and less disruptive in actually implementing these types of projects in the future. So with this project specifically, they improve the thermal performance, improving the R factor. In windows and fenestration, you're probably familiar with U factor as a primary driver, but most people represent or recognize a R value as easier to understand. It also improved the energy efficiency, and along with all of the 8 initiatives, so they save 38% of their energy bill, or $4.4 million overall. $400,000 a year in just the window improvements alone. So, and that reduced 105,000 metric tons over the 15 years. So the return on investment on this project overall was reasonably good, 3.1 years. I mean, you won't see that in a residential environment. It's much, much greater. For those of you that have modeled residential upgrades, you're looking at anywhere from 8 to 15 years or longer when you look at improving or trying to recover your investment. So what we've done is, these are a few of the numbers that we've put together as relates to the improvements that we're looking at with a film. Now, the film was originally, we designed it to control the passage of light, tintable film. You might be familiar with electrochromics or SPD. They really don't have a lot of inherent energy insulating value and solar gain control, but what we have here performs exactly that. So you not only can control the passage of light through the window, but you can also improve the U value and your solar heat gain coefficient significantly with just the application of an external film. So you don't have to go out and actually replace the fenestration, rebuild your IGUs and so forth. So better than 0.09 on the U value is what we have modeled, and the modeling is very effective for fenestration if you're familiar with the work that's done at the Lawrence Berkeley Laboratories and some of the software that supports it. Variable control, so depending on your tinting settings, and SHGC that ranges from 0.09 to 0.30. So you can actually control your solar gain. So the solar gain when you need it, when you want more, what can be lightened up so you can increase your solar gain or decrease it when you're trying to block out more of that solar gain. So that helps a great deal. And of course, we talked about some of the systems that can control this. Building energy management systems. In essence, you can control your windows the same way that you can control any kind of lighting system, wireless, EMS, BMS, the manual, and so forth. So, and of course, that'll reduce the carbon emissions as a result of reducing the demand for fossil fuels. So as we looked at this, just as it relates to any energy efficiency project, the things that you need to look at is the affordability. Can we really provide, can anyone who's delivering this, whether it's a new technology that's coming out that is disruptive, or if it's an existing product such as a solar film that's applied, is it affordable to the consumer? And also, does it provide the kinds of returns that will help them recover their cost or their investment over time? The performance, of course, you want something that is going to make a difference. You don't want to just have incremental improvements. You want to have a significant or drastic improvements in both your architectural value, in other words, something like being able to control the passage of light to eliminate blinds and shades and shutters and so forth, but also the insulating value and control of the solar gain. So it's also very important. Environmental, of course, reducing the demand and reducing carbon emissions and the demand for energy, and of course, comfort. Being able to control it so the consumer is more comfortable in the areas that they're occupying. So strategic partnerships, we're looking at this from a perspective of bringing a new product to market, and also how do we integrate this with the different companies that will deploy this over time and integrate it into their new windows and retrofit new buildings as they're coming about. So different building efficiency specialists, and also Johnson Controls was a good example of what they did at the Empire State Building on that project. Of course, power companies, utility companies, and the programs that they have supporting the different initiatives that are outstanding. Different coalition like the Alliance to Save Energy is a very good area when you look at trying to manage and understand the different options that are available to you and the impact of those options. And then, of course, any kind of financial institution that is providing a program that will help you deploy what it is you're trying to do in the way of energy conservation. It has been said through several different studies that at times conserving energy is more valuable, provide you a better return than trying to generate renewables. Photovoltaics are certainly impressive, and it is a great deployment to have a photovoltaic system, but in some cases you can save more energy through conservation in programs such as this than by trying to generate power through new renewable systems. So something that no one should be ignoring as they evaluate their alternatives and where they're going to spend their money. So, thank you.
Thank you, Steve. Next speaker is John Frank. John joined CH2M Hill in 2007 with 25 years of experience of business management, design, construction of major semiconductor operations, and engineering management. He has been involved globally in many challenging and leading-edge technology projects, including multiple site selection programs, financial analysis, site and community developments, incentive package creation, client executive sponsorship, photovoltaic, renewable energy, flat panel, 300 millimeter, 450 millimeter semiconductor and nanotechnology related projects. Prior to becoming part of the CH2M Hill team, John was responsible for the electronics business unit of M&W Zander, Hitachi Semiconductor America Inc., and Zilog Corporation's construction, facilities, and semiconductor operations as the Vice President of Operations. John also worked for 5 years with Sematech, where his team was recognized for achieving the first 200 millimeter, 250 nanometer devices. Boy, that was a long time ago, John.
A long time ago.
John graduated with a BS in chemical engineering from the State University of New York at Buffalo. John.
Good afternoon. Pradeep, thanks for inviting me into the College of Nanoscale Science and Engineering. I guess I'll have to update that hot shot sheet because that's pretty old now, not much bragging rights. Today I wanted to share with you some of the energy efficiency partnerships that we at CH2M Hill have been involved in. One of the key ones that a lot of people here may have heard about, especially as people are incubating new technologies, products like what Steve's talking about, is Masdar City, for instance, over in Abu Dhabi. That's been an exciting project, and we've had the opportunity to deploy on a large scale a number of new ideas to see how well they meet into fruition, if they can achieve that value engineering that Bob was talking about too. So I'll touch on this. My thoughts on this was that looking at a lean project delivery, and one of the things we continue to evolve in, you heard in Pradeep's opening a lot of the big projects that we've been involved in. Key element in those projects has been to make them more lean, to make them move more efficiently. And one of the elements is to bring that design, the new ideas during the programming session to the construction and using much more of an integrated schedule type development. And so I'll share with how that rapid prototyping, which enables a lot of these good ideas, the building size, some of the shading effects that was being discussed, and those energy efficiency elements which may drive the actual building shape and size and placement and location at the front end of the job too. So those are some of the important aspects that have been learned through these. And then I'm going to finalize with what we've learned as CH2M Hill in the sense of moving through projects on ourselves and walking the talk itself, because we've been pushing for sustainability throughout all the firm's operations. So from a lean perspective, we looked at all the elements that make parts of the project. We heard about materials, the new materials that are coming aboard, the effectivity of those materials. Are they able to meet the R values that are being suggested out there? What's the reliability, the weatherability of those materials too? So it takes an incorporation of a lot of these things on a global basis to see how they're going to actually stand up. When we were doing very large, for instance, PV utility scale solar farms in hot southwest climates, one of the problems were how to keep the panels clean. So using a little electrostatic discharge to help push some of the particles off, a washing system, all those are a little bit more invasive, and that adds cost to the projects too. So you need to be able to incorporate those type of items. So as we look at these projects, we've come to the conclusion that you really need to engage the key stakeholders at the front of the job. And when you're looking at the lean part of this project in regards to the people that are going to be involved, what your deliverables are, all those items, again, really need to come in at the front end of the job. And then understanding what are the different participants are going to be in the project and the key goals. One of the things we like to look at is when is the actual revenue generation needs to occur on the project itself, and developing that in the schedule, and then fill in the construction and design schedule from that. That'll tell you how much time that you probably could be permitted to look at or analyze new materials and some of the leading edge opportunities to incorporate some new energy efficiency elements. Cost of ownership on both the new materials, are they really proven? Have they been effective? Have they met their needs? Those are the type of things that we're often asked at the front of the job to be able to truly see if those value engineering opportunities can be taken advantage of. So in the integrated project approach that I mentioned, the impact on the red is a curve that I call the ability to influence cost and energy savings. So at the beginning of the job, we have a huge opportunity during the programming and design aspects to be able to actually cause those things to come in. If we're going to go for a lead, it's one of the first questions we ask. We're going to try to be platinum, silver, gold. Where are we going with this? For instance, we did a fab, actually the first fab in the world that was done to a lead silver, and the admin was lead gold facility. We did this some years ago. It required the owner being heavily engaged, and actually, definitely this owner took a leadership role in making that happen. That was at the very front end of the project.